So hello namaskar to the all chemistry lovers and doctors and engineers of the near future. मैं विजय कुमार सोनी आपका स्वागत करता हूं केमिस्ट्री वाला चैनल में regarding to just chemistry. In previous video we have discussed about a lot of things regarding to just haloalkane and haloarine and preparation methods separately with the haloalkane and separately with the haloarine. Now I would like to go with some additional techniques of the preparation methods of haloalkane and haloarine. So we can see that some some additional methods of haloalkane and haloarine of Rx and ARX. This is the very important. If I will go with the first, then we can take biether. This is the biether. As a ether, we can take ROR as a formula. This is the ROR. On reaction with PCl5, what will be? It will dissociate in Cl and Cl. We have discussed about the dissociation of PCl5. So here will formation of two molecule of RCl chloroalkane with the POCl3. This is the chloroalkane. If I go with the example, then I can take just C2H5, OC2H5 as a diethyl ether. This is the PCl5. It can dissociate in PCl3 and ClCl. Here will formation of chloroethane as a C2H5Cl, two molecule, and POCl3, phosphoryl chloride. This is the chloroethane. This is chloroethane. If I go with another method, then we can get just haloalkane also from amines. Regarding to amines, it will use of one of the important reagent that is called as NaCl. It is also known as just nitrosyl chloride. Or it is also called as Tilden's reagent. If we'll go with the preparation method, then we can take just the formula RnH2. This is the NaCl. We can write it as follows. This is the Cl. Here will formation of one of the water molecule, separation of N2, and here will just chloroalkane with the removal of water and N2. Chloroalkane. As a R, we can take just C2H5 as a ethane amine. This is the NaCl, Tilden's reagent. Here will formation of C2H5Cl as a chloroethane, and here will formation of N2 plus H2O. Here, this is the most important part. What is that? These reactions are helpful in the interconversion also. So this is the NaCl is known as Tilden's reagent, the other name of the just nitrosyl chloride, and this is the common phosphorus pentachloride. Now the time to discuss about the third method as an additional method. What is that? Listen me carefully. So this is the third method from dihalides. This is the third method from dihalides. If you go with the dihalides, then there are two important dihalides as Zam and Visnal, by which we can get just haloalkane also. If you go with the Zam dihalide, then the halogen atom will present on a same carbon atom like this. So on reduction in the presence of ZnCu, and concentrated HCl, we can take HCl also. So here will be one of the HCl and one of the H will be over here. So here will formation of RCH2X with the removal of HX. This is the halo alkane. If we go with the this was about the gem dihalide. Gem dihalide. As a gem dihalide, suppose we are taking here CH3, CHCl and Cl. Reaction with 2 of H plus means reduction. Same condition. Then here will formation of CH3, CH2Cl with the removal of HCl. This is called as chloroethane. So this was about the third method as a dihalide, gem dihalide. If we go with the vicinal dihalide, suppose this is the CS2Br, this is the CS2Br. On taking same reduction and under same condition, so here will removal of one of the HBr like this, and rest one of the H will be over here. So here will formation of again haloalkane as a monohaloalkane. You can say bromoethane. So this was about the from dihalides. If we'll go with the further methods of preparation of haloarine, then we can take just from phenol. This is the most important. It will also in the phenol. Regarding to phenol, we can take the formula C6H5OH. Here is the PCl5 which dissociate in PCl3 and ClCl. So here will formation of C6H5Cl plus one of the molecule of POCl3, phosphoryl chloride and another molecule of HCl. This is the chloroethane. So this was about the 4 important techniques as additional techniques for the haloalkane and haloarine. Now the time to discuss about the nature of CX bond in haloalkane and haloarine both. We'll take them separately because of it's too important. How we'll take them separately? This is the separate part for the both. So these are the just nature of CX bond. This is the nature of CX bond. First of all, I would like to go with the just A part for haloalkane. Haloalkane. If I'll go with the haloalkane, then as we all know that what is that? If we'll go with the just haloalkane, then this is the example RCS2X. This carbon is in sp3 hybridization condition because of all are the sigma bond. Due to having sp3 hybridization, its geometry will be tetrahedral. Tetrahedral geometry. This is the most important. The bond angle will be with the proper value, that is the 109 degree 28 minute as a value of bond angle for the haloalkane. Now the time to discuss about the nature. So if we'll go with the nature of haloalkane, then in haloalkane this is the formula Rx. Electronegativity of halogen atom is larger than the alkyl group. So what we can say that it exhibits polar nature due to having partial charge. Haloalkane or alkyl halide exhibits polar nature, and due to polar nature, these also exist following kinds of the bond. This is the Rx, this is the Rx, this is the Rx. So due to partial charge as a minus, plus, minus, plus, minus and plus, here will a force of attraction, ये वाला जो पॉजिटिव है ये इस नेगेटिव को अट्रैक्ट करेगा, ये नेगेटिव इस पॉजिटिव को अट्रैक्ट करेगा. So here will be the presence of bond as a dipole interaction force, interaction force. If you go with the dipole interaction force, then it is stronger than the van der Waals forces. It's a one of the kind of the just van der Waals forces also, but it's stronger than the just non-polar. So that's why if we'll go with the boiling point of alkane and haloalkane, then the haloalkane exhibits more value of boiling point than their alkanes also. These are the formula. This is the formula for alkane and this is for haloalkane. Haloalkane. Now the time to discuss about the further properties. Due to having just polar nature, due to, you can say, due to polar nature, you all know about the sequence of electronegativity of halogen, that is your F, Cl, Br and I. Electronegativity in a group decreases. So what will be, just you can say, there are two important things. One of the is your bond length for the particular alkyl halide for the different halogen. This is the Rf, this is the RCl, this is the RBr and this is the Ri. This is for the just bond length. Then we'll say the bond length is increases and the bond dissociation enthalpy, bond dissociation enthalpy, the sequence will be just larger size, so it will require less amount of energy. So bond dissociation enthalpy or bond enthalpy sequence will be your as follows. This is the Rf, this is the RCl, this is the RBr and this is the Ri. So the sequence will be bond dissociation enthalpy decreases as follows. It will be larger for the fluoroalkane and lesser for the iodoalkane. Here we can take one of the important thing also, and this is for whenever R is equals to, remember one thing, R is equals to CH3 group. If we'll go with the just another thing, that is the dipole moment. Dipole moment you have discussed in class 11th also. Just mu is equals to Q into D. Then what will be just dipole moment? Mu is equals to Q into D. Distance increases, so dipole moment also just here will be the distance is higher but electronegativity is lesser. So value of Q will be lesser. So in that case, dipole moment regarding sequence RF lesser will be higher than the RCl, higher than the RBr and higher than the Ri. This was about the just bond dissociation enthalpy and dipole moment and entire part of the nature of the CX bond of the haloalkane. Now I would like to go with the just nature of CX bond for haloaline as a B part. This is the B part as a B part as a nature of CX bond for haloarine. The formula for haloarine is ARX. This is very important. If we'll go with the structure of haloarine, then you all know just benzene ring always exists sp2 hybridization. So here halogen atom will attach by the just sp2 hybridized carbon atom in haloarine specifically. And what will be the common thing that is very important for us to know, because of this is depend on the just reactivity of the nucleophilic substitution reaction also. So if you will go with the just nature of CX bond of ARX, then this is the benzene ring, most important thing. This is the benzene ring and this is the halogen. In the conjugation with the pi bond, here will sp2 hybridization, sp2 hybridization with the geometry of trigonal planar and the of bond angle of 120 degree regarding to just your, while on the other hand for the haloalkane it was sp3 tetrahedral and 109 degree 28 minute. If I'll go with the just further, then you can say in haloarine, in haloarine just X will in conjugation with just pi bonds of pi bonds of you can say benzene ring, or in another word you can say what is that, in haloarine just electron of halogen atom will be in conjugation with the pi bonds. So shows resonance, because of due to conjugation between either two pi bond or just one lone pair or one pi bond, it will be resonance. If we go with the resonating structure, then what is that? This is the benzene, another structure of benzene. This is the another third structure of benzene, fourth, and this is the fifth. Here will five canonical structures due to proposed by the two of the, you can say two of the proposed by Kekule and three of the proposed by Deva. So here is your, you can say Cl with the three lone pair. It donates one of the lone pair over here. The valency of carbon may not as a 5, so shifting of electron will be as follows. So the next condition will be, here will be double bond Cl. From the lone pair of 3, it will be 2 with a positive charge, here will negative charge. This is the condition. For the next condition, if it donates over here, then shifting of electron will be over here. So here will be negative charge, here will double bond Cl with the two lone pair and positive charge. In the next condition, what will be? It shifts over here, so this will be the next structure. So Cl, this is the positive charge. In the next step, it will be as follows. Similar with the first structure, not exact with the first structure, it will be similar with the first structure. So these are the five canonical structures. From these canonical structure, five canonical structure, what we can say that? We can say that it will be partial double bond character. It will be partial double bond character. It will partial double bond character between CX bond of haloarine. This is the partial double bond character. That's why we can say that it is not easier to dissociate the bond as compared to just CX bond of haloalkane, means it will be more reactive as compared to haloarine. So we can say that these are the stable and these are the more reactive. These are the more reactive. So these will be less stable, and these are stable, so less reactive toward the this cleavage of CX bond. So this was the entire part of the this nature of CX bond of haloalkane and haloarine. So we will meet with the next video with the new properties as a physical properties of the haloalkane and haloarine. Till then, shukriya, dhanyawad. But this video is too important for you because of it covers a lot of conceptual question. Thank you.